All right, let's talk about the internet. Specifically, let's get into the invisible forces that are constantly deciding just how fast or how frustratingly slow your connection is going to be. We're going to break down why we still get those digital traffic jams and how some really smart AI is being built to finally clear the road. So let's start with something we've all felt. You're paying for super fast internet, you've got the best router, you're sitting right next to it, and you're still staring at that spinning wheel of death. What is going on?
Well, here's the deal. The problem usually isn't your Wi-Fi. It's congestion out on the wild highways of the internet. You have to imagine it like a massive global traffic jam where all your data, every piece of that video you're trying to watch, is a tiny car and they're all getting stuck.
So let's really dig into this idea of a digital traffic jam. To figure out how to fix it, we first have to get a handle on what network congestion really is and why it even happens.
It's actually pretty simple when you think about it. It's just too many data packets trying to get through the same narrow point at the same time. It's a bottleneck. And when that happens, you get delays. Even worse, sometimes packets just get dropped completely. Think of them as digital fender benders. And that's the moment your video call freezes up. Okay, so for decades, literally decades, the internet's traffic cops have had a very simple and honestly kind of clumsy strategy. They just wait for a crash to happen and then they react. The algorithms that are still running a huge chunk of the internet today, like one called cubic, are what we call loss-based. They're purely reactive. They aren't looking ahead to prevent a traffic jam. Nope. They wait until they see the wreckage, the lost packets of data, and only then do they slam on the brakes. This whole approach is basically like a driver who only slows down after hitting the car in front of them. It works like this. It senses that there's a problem only when it detects a crash, that packet loss we talked about. Then, boom, it cuts the speed way down, and then ever so slowly starts to speed back up to test the waters. You can probably guess this is not the most efficient way to run a highway. And this slide, wow, it really lays out the two completely different ways of thinking. On one side, you've got the old way, wait for a problem, then react. But on the other side, a new philosophy started to take shape. What if we could actually avoid the jam altogether? And that new idea, it landed in 2016 when Google rolled out a totally new algorithm. It's called BBR, and it was designed from the ground up to be a proactive driver, one that's always scanning the road ahead instead of just looking in the rearview mirror for crashes. See, BBR doesn't wait to see lost packets. Instead, it's constantly building a live model of the network path. It's like the Waze for your data packets. It's always sending out little feelers to measure how much bandwidth is truly available and what the delay is, trying to find that perfect sweet spot, the absolute fastest it can go without causing a backup. And it does this with this really clever four-step dance. First, it just floors it, the startup phase, to see how fast the road can really go. Then it eases off the gas to drain any little queue it might have just built up. After that, it mostly cruises, but every now and then it'll poke the accelerator to see if more speed is available. And periodically, it slows way down on purpose, just to get a super clean measurement of the true delay. It's this constant cycle of learning. This timeline really puts the whole story into perspective. I mean, for nearly 30 years, we were stuck with those purely reactive systems. Then BBR shows up in 2016 and totally changes the game. But as you can see, the evolution didn't stop there. Because, as it turns out, there was a catch. And there's always a catch, right? BBR's aggressive, speed-at-all-costs nature came with a pretty serious side effect. It wasn't exactly a great neighbor on the digital highway. So here's the core of the problem. BBR is so incredibly good at finding and using every last drop of bandwidth that it can end up starving out other connections. That older algorithm, cubic, is programmed to be polite. When it sees the pipe filling up, it backs off. But BBR, it just keeps on taking. It basically acts like a roadhog, creating a really unfair situation. And hey, don't just take my word for it. The research totally backed this up. This quote here basically says that when you put BBR on the same road as other protocols, its aggressiveness can directly mess with the network's fairness for everyone else. Now, to their credit, Google has been trying to teach BBR some manners. Version 2 and the newer version 3 were designed specifically to be better neighbors, to pay a little more attention to things like packet loss so they aren't quite so pushy. And they've helped. But that core challenge, that balancing act between being fast and being fair, well, that's a really tough nut to crack with just a fixed set of rules. So if programmed rules can't quite get the job done, what's the next step? Well, the latest thinking is to stop trying to write the perfect rules altogether. Instead, what if you could give the algorithm a super smart AI copilot that could learn and adapt on the fly? And this is where we get to the really cutting-edge stuff. The research we're talking about today wants to use machine learning to build a version of BBR that makes smarter, more nuanced decisions in real time based on exactly what's happening on the network right now.
Now, what's really cool is that this isn't just one giant, clunky AI. The researchers came up with a much more elegant solution, a specialized two-part system designed for this very specific challenge. Okay, so here's how this 1-2 punch works. First, you have the classifier. Its job is to look at all the live data and figure out what BBR is trying to do. Is it in that pedal-to-the-metal startup phase, or is it just cruising? Then, once it knows the context, it tags in the second part, the optimizer. The optimizer takes that context and calculates the perfect sending speed for that exact moment, one that's designed to be both blazing fast and fair to everybody else. So, okay, that was a lot of tech. Algorithms, AI models, data packets. But why does any of it really matter to you and me? What does this mean for us when we're just trying to watch a movie? Well, it all boils down to an internet that just works better. It means less buffering, video calls that don't freeze up in the middle of an important meeting, and an online experience that's fast and stable for everyone, not just for the connection that happens to be shouting the loudest. It's really about building a smarter, more cooperative internet for all of us. And that kind of leaves us with this one big fascinating question. For years, we've had to choose. Our algorithms could be polite and a bit slow, or they could be fast and, well, kind of a jerk. This new research suggests that AI might finally be the key to teaching them how to be both. How to finally, after all these years, share the road. And if that works, it could change everything.